Okay, oscilloscope kit. So this was out of a need to see what is happening in the electronic circuits that I'm constructing. And oscilloscopes can be had on eBay, probably for £50 to £70 for a cheap one, but then if it's got a problem you've got to fix it. And I thought, well, are these electronic ones actually any good? There's only one way to find out. So rather than risk several £100 on a sophisticated one, I've elected for a single channel one that goes up to 200 kilohertz. It costs less than £10 for the circuit board and components, and about £6 to £7 for the case. Pretty primitive stuff, but if this piques your interest, or it's going to be the first time you've used an oscilloscope, it can be a very useful device. If you want to do advanced electronics, you're going to have to spend a lot more. I think the cheapest twin channel one was about £70 at a glance, and then you're into hundreds of pounds for a multi-channel one with a high bandwidth. So simple 200 kilohertz one, probably not got a very wide range of inputs, but for the sort of thing you're going to do with single board computers, this should be adequate, and it costs so little money that if you decide to get a more expensive one later on, there's no waste. Okay, so there's two packages. The case we'll look at later. Then there's the board. Now the board's available in three versions. You can get a completely naked one. Sorry, I'm rattling. You can get a completely naked one where you have to solder all of the components yourself. And, you know, we did that with the digital clock. But this is a little bit more important to me, so I'll let them solder all of the surface mount components. It actually costs more to get the board this way than it does fully assembled in many cases. And the reason for that is the quantity that they sell. They probably sell more fully assembled. But hey, where's the fun in that? So, here we are. We're going to have to put rather a lot of components in here. It's going to take quite a lot of time. You will need a multimeter because these are the 5-channel resistors, 5-band resistors that are fairly difficult to read even when you're quite experienced. So it makes sense to check them with a meter and put them into batches, label them up, and they're absolutely tiny looking at them as well. That's another reason, so it's quite difficult to read the resistors and capacitors, etc. So if you have a multimeter or a component tester, that's going to make it a lot simpler. So we'll do the assembly first, and I'll edit it so we just show the highlights, because it's going to take me a couple of hours at least. And then the initial testing of the board. It does require an external power supply, and it may even have come without instructions, but I think I know where I can find them. So we'll have a look at that. So let's open it up first. So this is the circuit board first, and there are a few versions of this available. They're all called DSO, and it's an O, not a 1. DSO, digital scope something, oscilloscope, 138. And they're actually, the original was made by a company called JYETech, and the JYETech ones you can always spot because they have an individual number on here. This is a fake, but it uses the same components and will load the same software. So yeah, I have read several reviews of these myself. They all seem to work. It's a little unconventional in the way that it works, but we'll go into that later on. So here we are, it runs off 9 volts, and it is 9 volts, you can't put 12 in. 3 switches here. This one sets the coupling to AC, DC, or grounds out the input for safety when you're not using it. This selects the sensitivity from 1 volt per div to 0.1 volts to 10 millivolts. And then to make it more versatile, there's a multiplier of ×1, ×2, ×5. That's the basic essence of it. There's a micro USB port to allow you to upload software to it, and it has a built-in test generator which is 1 kHz, 3.3 volts peak to peak. That couldn't be any more convenient for Arduinos if it tried, because you could then use that to inject a signal into an Arduino and work with it. Then the buttons here are OK, plus, minus and set. There's a reset button here, and a few other things I've not figured out yet, but that's at a glance. But I ordered this a couple of weeks ago and I've been waiting to get the time to look at it properly. So that's the board, one bag of components, user manual, and rather primitive but nonetheless perfectly functional test lead. That's a bit flimsy here. You can buy the proper scope probes with the ×1 ×10 multipliers in, so if you needed to work with a wider range of voltages and higher frequencies than audio, I seriously suggest you get one. They have the little clip on that you pull and the probe is exposed and you can hook it round the leg of a component. These are going to be quite difficult to use on individual components, but they are what they are. And the display sits on top of the board. So, and this is the other reason. Well, one of the things I noticed with a few of these was that the LCD display had been mounted skew with, but I believe you could heat it up with a hairdryer or a hot air gun if you're very, very careful, and you could realign it. To be fair, this one is not far off. I don't think I'll be wasting any time trying to move it. Oh, it does actually slide a little bit. I'm going to leave the protective covering on. This is it, just got a tag there. But that is ready made for you. That's going to go, probably helps if I move this over here. So that's going to mount on there after the other components have gone on. And as you can see, it's got a bus connector. And they've done most of the hard work for you. I'm not sure what this is about. I don't think it's needed. This is a 2.4 inch display. And again, we're dealing more than likely we're going to be dealing with digital signals. So you just want to see, have you got a signal? What's the duty cycle of it? Possibly what's the frequency? What's the height of it? And I have witnessed on the other reviews that this should do all of that. So, right. And unlike most times when I do kits, I shall follow the instructions. Just plug in the soldering iron in, as I've forgotten to do it. Can't get it in because the Raspberry Pi adapter is wider. There we go. And here's our components, which are in a resealable bag. Once we take the end off. Can't imagine ever wanting... Well, you never know, you get components left over. And it's a nice anti-static bag, or a reasonable impersonator of an anti-static bag. Oh. No? So yeah, no idea what's going on with it. Oh, you have to fit your own socket for the display. And I think that'll bring it up to the right height as well. So yeah, that's good. Header here. So I'll just lay these out in some semblance of order, starting with the largest ones. This is a BNC socket for the input. 3 nylon standoffs or 4 nylon standoffs, so that the board can sit in its case. some switches, micro USB socket, DC jack, and then some push buttons. A little 2-pin connector for probably for the test tone. Some more switches, a coil. These are always tricky to work out the value of, but I believe it's the only coil, probably for a DC-DC converter. Another socket, a large number of capacitors. We'll need to investigate the values of these later. Another 2-pin header, a crystal, 2 preset capacitors or variable capacitors. They are preset because you normally leave them set. A massive green LED and 1, 2, 3, 4, and they're not transistors. 2 of them are transistors and 2 of them are voltage regulators. And as usual, I can't see a thing, so they will require investigating. Now I believe there's the 2 voltage regulators are a 7.8 LO5 and a 7.9 LO5. And it's important not to get them mixed up for 2 reasons. Firstly, one gives out plus 5 volts and the other gives out minus 5 volts when it's connected to a negative supply. The other thing is that the pinouts are turned round on them, so it can damage them if you plug them in the wrong positions. They are either larger resistors or they are coils. There's a diode, and I'm just picking out the odd components. That is a very, very tiny resistor, but then I'll just gather some more resistors together. They're all resistors, unless one of them's a coil. Little decoupling capacitors, and there are flipping loads of them. But again, things that convert analog and digital signals, it's only to be expected. They have to be decoupled from the power supply. Another diode in there. And again, like the digital clock kit, it would be a very good idea to use 1/2 mil solder or something approaching 1/2 mil, 0.6 mil. Right, so those are all gathered in shot now, just so you can see how many components there are. Let's bring this in here. There we go. That is our oscilloscope that we're going to build. And I've subtly marked the area on the desk that the camera covers to make sure I get them all in. You can probably see a pencil line round here if it shows up on the video. So there we have it. Now we can start assembling. So firstly we'll have a look at the instructions. And there's some hints about soldering. You will need a pair of sharp snips to cut the wires off. And I say sharp ones because if you use blunt ones, it'll damage the circuit board underneath. So there we are, we've got a list of all the parts. Helps you to identify them. Yeah, 2 regulators, 7905, 7805, and 2 transistors which are Q8550 and 9014. Loads of ceramic capacitors, 3 100 microhenry chokes, which I believe are these down here. The diodes, always easily to identify, and the side with the line on is the cathode. Current goes from anode to cathode. The Crystal is an 8 MHz crystal, and the whole timing of the oscilloscope is based on that. An LED, which we assume is for the power. Tactile switches, so you press them and then they're off when you release them. Just give a temporary contact to change modes on this. Trimmer capacitors, a power inductor 1 mH, that's the big fella that has become invisible. There it is, big inductor. Electrolytic capacitors, and they're all 100 microfarads. Apparently. So you can't get those mixed up. Power connector, a header pin, which is optional. I'll fit it anyway. A pin header female, 2 pin and 20 pin, 3 slide switches, which are twin pole, triple throw. Really? Yeah, because the 3 positions. So they're moving 2 poles from off, left, right, or 3 completely different connections. And a BNC connector. A test signal ring, so that presumably puts the test signal straight into the scope without you putting a pin on it. A jumper, an LCD board, where to check the voltages, attach the LCD board, and a troubleshooting chart. Oh, I see, there's an LED. The LED indicates, it blinks twice on boot up to show you it's loaded the software. Yeah, interesting stuff. So that's one part of it, and then the rest of it is how to use, so we'll come back to that. And there's a circuit diagram. Quite interesting. There's a lot of analog electronics up front to set the sensitivity. There's some tuning capacitors to set the frequency response, so you can use built-in 1 kHz square wave to do that. And then the actual oscilloscope logic, and then the display is self-contained. Here's the power supply section. So you've got 9 volts coming in, -5 out there, so there's a buck converter here. And then there's another one here, so you're 9 volts in, and then that's 5 volts out. Okay, I'm reading this for the first time, so don't blame me if it's wrong. And then there's a USB port and a UART, which is, I know what it stands for, it's Universal Asynchronous Receive and Transmit. That's something you're unlikely to use on an oscilloscope, but the provision is there. So yeah, some nice stuff. Reset switch straight onto the microprocessor. There's the crystal. That's the power input, 3.3 volts. 3.3 volts to here. And I assume the data lines just go straight to the display. Yeah, there we go. DB02468 and DB1357. So those are the inputs into the display. Then the nice thing is we don't have to worry about how it works. There's some typical displays. The display on this is truly multi-mode, so you can just display the waveform, or you can display all the stats around it if you can afford a bit of screen space. So it's quite versatile. It displays things like the frequency, peak to peak, and average voltages. For 15 or 20 quid, I don't think you could want a better tool. Right then, time to start assembling. So I'm going to do it in the order that they do here. It's not going to be possible really to display the instructions at the same time as I'm soldering it. But I'll be doing it in the order that they come. But I'll sit down first and I'll separate the resistors out and measure them, which should be fun because I can barely see them. But that's not your problem. Okay, so I'll pause here. I'll get things set up into an order of assembly and then we'll come back.